So now we kind of go back to that discussion that we started with about how the solar radiation, particularly the UV radiation from the sun, are protected from reaching the surface of the earth where humans and other organisms live. And these UV radiation can be harmful to us. There's two levels of protection, the ozone layer being a major one, and then oxygen, of course, that surrounds us in the atmosphere. Now, why do these two molecules work in terms of blocking those radiation? The reason is because the chemical bonds that exist in both oxygen and ozone can absorb different wavelengths of light. So this is one of those discoveries that was made some time ago, that if you shine light of a specific type, a molecule can absorb that light if the bond has the same strength of energy as the radiation itself. If you remember the structure of oxygen, which is this molecule right here, and then ozone, which has three, right? Oxygen has a double bond. Oxygen will be able to absorb radiation that has a higher energy because it has a double bond. So that means if you're looking at the UV radiation, it's going to absorb something with a lower wavelength, because remember, lower wavelength equals higher energy. So when we look at the UV radiation from the sun, UVC, UVB, and UVA, mainly the UVC, is going to be absorbed by the oxygen molecule. And ozone has a double and a single bond when you draw the molecule together. In reality, you average out those double and single, so it's like having a 1.5 bond. That's what we see in the real ozone molecule. A 1.5 bond is not as strong as a double bond, so ozone will be able to absorb energy, but it's going to be energy that is lower than what oxygen absorbs. That means it's going to absorb something at a higher wavelength. So you can see here in this chemical equation, oxygen absorbs UV light that has a wavelength of less than 242.5 nanometers, whereas ozone absorbs UV light less than 308 nanometers. So it's a bigger number, right? Which means a lower energy. If the ozone and oxygen doesn't surround our atmosphere, we're basically going to get bombarded by these UV rays on the surface of the earth, and a lot of problems will happen as a result of that. What kind of problems can happen? Particularly important is its effect on biological molecules like DNA. If radiation hits a DNA molecule, shown here, it's called a double helix. They're made up of atoms that are bonded to each other. Those bonds, just like oxygen and ozone, can also absorb radiation energy. So if a radiation comes in at the right wavelength with the right amount of energy, the molecules in here that have the bonds can absorb that radiation, and then that would actually break the bond. We call that process a mutation. It basically just means a change. But when you change the structure of the DNA, you're changing the central molecule that determines how everything else works. Once this mutation happens, you can have all kinds of other problems like cancer and things that is abnormal in terms of the biological processes. The skin can also absorb these UV, A, B, and C radiation. Different levels of skin can absorb different types of UV light, again, because of the molecules that are present in those skin tissues and skin cells. The effect on us could be skin cancer, premature aging, sunburn, etc., etc. Those are all effects of UV radiation on your skin cells. People noticed back in the late 70s that the ozone layer, which exists in the stratosphere, has a hole in it, which just means that it's thinning out. The ozone molecules themselves reacted with a number of chemicals that humans use at the time. They're called chlorofluorocarbons, or CFCs. These chlorofluorocarbons are things that you find in refrigerants, so for your refrigerators or air conditioning of any kind, whether it's in plants, homes, or automobiles. So all of these usage of the CFCs, the molecules are gases, and these gases go up all the way to the stratosphere, and then they react with the ozone. And because they are converted, then the amount of ozone available in the stratosphere decreases, and therefore more UV light is able to pass through to get to the surface of the earth. That's obviously bad news. Once people realize that, there's a meeting of a number of major countries at the time saying that, hey, we got to stop using these CFCs. So they signed what's called a Montreal Protocol, because that's where the meeting was. And the agreement is to lower or remove completely the use of CFCs in everyday products. So actually there's a good improvement since the beginning of that process. That's 1970s is when it was first discovered. And you can see that this is just the total ozone in the ozone layer. So if the number is lower, that's a bad sign. That means that the ozone layer is thinning. But there is a good sign because it was recently measured again in 2022, and we noticed that now the number starts to increase in the past 10 years or so. It seems like we had hit bottom around the year 1998, and then it starts to slowly go up after the Montreal Protocol was signed. That's really a sign that as long as we collaborate, we're able to fix this major problems, because this is a problem that affects the entire Earth. So the prediction is that if we keep on doing what we're doing right now, we should be able to bring that ozone layer back to its level that we observed in prior years. Okay.